Hey y'all, Mr. Hanson here. I want to walk you through the first step I would take to approaching the systems diagram for this topic that we're working on, this mathematical modeling topic. So there's kind of two parts to this project that I'm asking you guys to turn in, is to come up with a systems diagram for your capstone project, and then create some mathematical models using some of the mathematical modeling tools that we've discussed to help you understand those different parts of your system. So what I've got here is our lovely FTC competition robot that I'm going to break down in terms of its subsystems and show you how to make a nice professional looking systems diagram that shows how the inputs and outputs of different parts of our systems are connected. And so this guy's got um, microcontroller that takes code and user input and transfers that to electrical signals through a bunch of wires. We got a battery. We got two drive motors in the back connected to our drive wheels, which makes things go and turn. And we've got a motor back here that's connected to a gear train that raises an arm up and down. That arm has a little gripper mechanism attached that can open and close, and we can grab an object and hold an object and move it around as part of the FTC robotics competition. So taking this guy and trying to break it down in terms of its subsystems so we can understand how each individual subsystem works and understand the math behind those subsystems and then do our engineering design for those subsystems. This is essentially what we're doing as engineers. So I've got my systems diagram pulled up here. I'll show you guys how to make a systems diagram like this here in a second. But this is using the Google Drawing tool. There's a couple different tools you can use to create a nice looking systems diagram. Google Drawing is relatively easy to use and obviously interfaces with all the Google software. So looking at this, I'm starting with sort of my inputs over here. I'm working my way towards the outputs of this system. So this whole thing is my FTC robot systems diagram. I've got a microcontroller that controls everything. I've got a power supply that provides 12 volts of electricity to the microcontroller. The microcontroller generates an electrical signal to drive arm motors, drive motors. And so I made a big block here for the frame because these motors are mounted directly to the frame. The arm motor, that's connected to my gear train is what lifts the arm up and down. And so I'm thinking about the input of the gear train is my arm motor. The output of this gear train is the position of the arm. So that's labeled here as the Z position of the arm. So I'm thinking about that as like the Z axis here. The up and down axis. And then the gripper motor is connected to the arm mechanically, and the Z position of the gripper depends on where the arm is positioned, obviously. And so that gripper can be open or closed. So I'm thinking of that as one of the states or the outputs of this system. The gripper can be open or closed. Kind of going along this bottom path, I've got drive motors connected to drive wheels, and those control the XY position of this robot. So that's its orientation as well as moving it around on sort of like the XY plane of the ground, as well as like the velocity that it's moving. So I might consider those outputs of my system. And so if I want to move my robot to grab a block to deposit in the goal for the robotics competition, I need to know the height of the gripper, whether the gripper is open and closed. I need to know where my robot is and how fast it's going. And so that's what I'm thinking about the outputs of this particular robot. This robot's got, I don't have it attached right now, but it's got an ultrasonic rangefinder attached to the front that helps with obstacle avoidance. And what that's essentially doing is taking my XY position, figuring out if there's an obstacle in front of me or a block that I want to pick up in front of me, and then sending a signal back to the microcontroller to automate some of the process for picking up the block. And so that's an example of how we can use a sensor In this case, just a rangefinder, a distance sensor to close the loop, part of the loop for this systems diagram. So this is a systems diagram. We could get into more details, and we will get into some of the math behind some of these components. In the next video I post. But I want to show you guys just briefly how to make a systems diagram look like this without too much trouble. So if you're in your Google Drive, you can open up Google Drawings. It's a block diagram drawing tool, and like I said, it's relatively straightforward to use. Our system diagram just consists of blocks, some text labels, some lines and arrows showing how inputs and outputs connect. And so you can create, just a simple rectangle here. So, this may be the, starting point of my systems diagram, which might be the microcontroller. Make that a little bit bigger. Let me add, I don't know, another block here. And so, for example, my controller might control DC motor. Let's see, that DC motor, let me just grab this guy, Control C, Control V. That might control 4-inch wheel. So here I've got different components of my project that I can kind of isolate and start trying to understand those components individually. Let me add some connectors between these. I'll just grab an arrow. Bam, there I've got a very basic systems diagram. Now, this is showing that the microcontroller provides some input to the DC motor that provides some input to a wheel. And so what I might want to do is specify what these inputs are. So for example, the microcontroller provides what's called a pulse width modulation signal to the DC motor. That's used to control the speed of the DC motor. That could be something you dig into and figure out what pulse width modulation is if you want to figure out that part of your systems diagram as part of your mathematical model. The DC motor, like we've talked about, DC motors, they provide a torque and a rotational speed to turn something. So torque is roughly, we can think of that as like the strength at which it's turning, and then of course the speed that it's turning at. And so we've gone over some notes that relate the torque and speed of the motor, and we have a model for that. So it's providing torque and speed to my wheel. And so if I'm labeling this arrow here, if I go up to Format, Insert Special Characters, we use the Greek letter tau to represent torque. So let me grab a tau, and we use Greek letter omega to represent rotational speed. Let me just stick a comma in between those. And so, the DC motor takes my electrical signal as an input and creates a rotational torque and rotational speed as an output, and that's provided to the wheel. And of course, the wheel is this fancy little device that takes that torque and rotational speed and turns that, in the case of my robot, into translational distance. The wheel rolls and the robot goes back and forth. The car goes back and forth. The motor turns. The propeller, the C-perch goes back and forth or up and down. So let me provide an output arrow here. And so the output of this little system that I've broken down in a couple different subsystems here would be position, and I'd also consider the velocity. Well, velocity incorporates that. Let's be slightly more precise and say speed. So, this wheel turns, it changes where my robot is. The wheel turns, that changes how fast my robot's moving. And so those are two outputs of this system. So this is maybe just kind of a cursory breakdown of the drive train system of this robot. And so that's how I would use Google Drawing to create your drawing. If you want to make things look a little bit fancier when you put them on your portfolio, let me just select all these arrows. I'd suggest making them a little bit thicker. Oof, wrong button. Go. Making those arrows thicker. Let me select the boxes here. You can change the color of the boxes to whatever you want. If you want to make them look a little nicer, if you go to Format Options, add a little drop shadow to them, gives them a little bit of depth, and that's typically how you see them presented in like engineering papers. But this, would be an example of part of the subsystem for this robot. And so we can do a little bit of math based on what we've talked about in class to, break down, what the DC motor is doing, what the wheel is doing. The wheel is a simple machine that translates axle force or torque into force or torque along the ground to create translational distance. The DC motor, like we said, takes an electrical signal and produces an output torque. And depending on what motor we're using, we can figure out what that expected output torque is going to be. So we're going to spend some time digging into like these different blocks and figuring out how to connect those inputs and outputs to get the outputs from these inputs. And so I'll post that in another video. But if you're making a systems diagram, this is a good tool to use. Real easy way to connect things using Google Drawings. So give that a shot. Make a nice looking professional systems diagram. And that'll be a good first step to getting your project working.